What's up, guys? In this episode, we are gonna code our own encryption library. It is loosely based on the ARC4 cipher, but with some improvements which makes it more secure. We're gonna expose a couple of functions from our library, and it's an initialization function which takes a key as an argument. There's a encrypt function and there's a decrypt function, and finally an uninitialization function. So it's very easy to use, and let's get started. Hello everyone, and welcome to today's show. Today we're gonna code our very own encryption library using the ARC4 algorithm. When talking about encryption, that is one of the more easy encryption ciphers to implement. But it's a little bit bigger project than we usually do, so I will not be coding inside of the terminal today. I will do most of the work through VS Code. So let's begin by launching the Sociopath SCP client, so we will be able to code live against the server. I will just go into I will put it in my temporary directory, and I will create a new directory, and I will call this ARC4, spelled like this. So the algorithm is written like this, RC4, but it's pronounced ARC4, so I think that's a good name for the library. So I'll simply create an empty folder, and I'll right click and open an editor. Then I will have access to the entire folder inside of VS Code, like so, and I will minimize my Sociopath and close down this, and I will also log into my server and attach to my screen, or I will create a new screen instead. And I will configure it, and as you run command VBL off, and as usual I will write a simple bash script like this, just so I don't accidentally close down this window and terminate the screen. So let's go into my temp directory and go into my ARC4, and here we are, an empty folder. So what do we need? I will create two files, or three actually. First I will have the actual code, the arc4.c, like so. And as I save, we can see here it's successfully updated to the server. And we will also need a arc4.h for our structures and includes and definitions and macros and such. And to make our life a little bit easier, I will also create a make file, which is going to compile the whole thing. And actually, I will create a fourth file as well. This is just a temporary file. We won't need this file when the project is completed. But as we are implementing this encryption, it will be easier if we have an example program which we can use to try things out. And I will call this example.c because we are creating a shared library. So this library will be used by different C projects, and that means that the arc4.c file will not have a main function. So this example.c will provide our temporary main function so we can run it. Alright, so in the make file, I will simply define the stuff that needs to be compiled. So the first thing will be arc4.o, and you write it like this. So the file that's the target, and then a colon, and then you write the dependencies. So this file will depend on arc4.c, like so. And then you tab and you write the command. So I will do gcc-c arc4.c, like this. And I will also turn on optimizations at the highest level, as well as log messages. And when that file has compiled successfully, we will have an arc4.o, and then we will create the actual arc4 library. So this depends on arc4.o, and I can't really remember how to let's see, all the flags necessary to create the shared library. So I will check how I did it in my Toralize make file. And I will simply copy this part right here. So I will do GCC, and we are compiling arc4.o, or linking actually, and the output will be called arc4.so. That's the extension for a shared library, and we want the optimizations and the logging, and then this additional flags necessary for a shared library. Okay. There we go. So after those two steps, our library is compiled, but I will also have the example .o dependent on example.c, gcc-c, example.c, and I will turn on optimizations and wall. And when we have the object file, we can compile example, which will need example.o, and then we simply do gcc example.o -o example wall 02. And I would also create a clean, which simply removes everything besides the source files. So all O files, all SO files, as well as the example binary executable. And then I will just tell the makefile what we should do as a default when we run the command. And I want to compile arc4 and example. So this is our makefile. If I didn't miss anything, I think we should be able to, let's just go into the temp and the arc4, and I will set this to my home, so the prompt won't be so big, like this. And I didn't save the .h file, I think, and the example and the make file. There we go, arc4, makefile, arc4.h, and example. So I should be able to run the make now, and we get a reference error for the main, but the .o file should have been created. Yes, they did. So everything seems to be working. Even the SO file did be created, even though everything is just empty source files. And if we do make clean, we're back to where we started. Okay, that's a little bit of administrative work, but it will pay off when we need to recompile and debug our code. I'll close down the makefile because we don't need to do much with that. And I will actually start with the example file because if we create the example first, then we have a kind of a roadmap to the different functions that we need to create later on. So I think that's a rather good way to start. I'm gonna include the arc4.h, arc4.h, and inside that I will have my regular definitions. So I usually start by putting in the stdio. That will be removed later on because we're not going to use any of these libraries, but during development I think it's easier to have all the usual standard libraries ready to go. Like so. Okay, so how will this example file work? I'm gonna start by just creating function definitions. So we do everything in the order that you should, even though this is a small file. So we'll have an int main with no arguments, and that'll be all for now. So I'll create the actual main, and I never seem to learn where to find my curly braces on my Mac. Alright, here they are. So I will make this file a little sloppy and easy to work with, because this will not be a part of our production code, so to speak. So I will just do it as easy as it can be for myself. So I'm going to create a couple of pointers. I will have one for the key, and I'll have one for the source text that we want to encrypt. I will have one for the destination text, and I will have one additional pointer for when we decrypt the encrypted text. So let's call this encrypted instead, and this decrypted. That's a little bit more obvious. And I think I need to make this a little bit smaller. I hope that won't be a problem for you. Okay, and I will just define this statically. So I will set the key to, let's see, something easy like tomatoes. When you run this code for real, you should always create a real encryption key. So this can really be anywhere from 8 bits to 2048 bits according to the standard. But this will do as an example. And the text I want to encrypt is a part of a Shakespeare poem. Shall I compare thee to a summer's day? Okay. We will also need to, before we do that, I need to define a couple of type definitions, because I'll be using 8 bits integers, and I will use 32 bits and possibly 16. So I'm going to define those first. So let's define we will do unsigned char, that is an 8-bit value, and I will call this int 8. Not defined, by the way. This should be a type definition. So a type definition is when you create your own type. Everything you write is what the source name is, and the last one is the destination. Okay, so the next type definition will be a 16-bit int, and that is defined in C as an unsigned short int. And I will call it int 60. And finally, we need an 8-bit variable as well. And I will type this as an unsigned char int 8. Oh, sorry, I have done that already. The only thing we have left is a regular 32-bit integer. And that will be a regular unsigned int like this. Okay, so now we have our type definitions. And let's continue with the example main function. So we have the string that we want to encrypt. We have the key. We will also have a pointer to a structure, which I will call arc4, and I will call this pointer arc4 like this. So this will contain the internal state of the encryption engine, so to speak. And I will define this as a let's do it here. I will do struct s. I usually prefix my structures with an s. That's a stylistic choice though. So s arc4, and what will this contain? Well, we will actually use the Wikipedia page. It's a very good Wikipedia page which tells exactly how to implement this encryption. Not in a specific language like C, but with pseudocode. Okay, so we have this, and now that we have the key, by the way, we also need 2 size variables. So let's do int 16, and what do we need? We need 2 size variables. So let's call those size key and size text. And I will just use this string length to define those. So s key equals strlen key, and s text equals strlen from. Okay, so now I have all that I need in order to call the first arc4 function, and that is called, let me do the function declaration. It will be called arc4 init, because it initializes the arc4 structure. So this will be of type arc4 pointer, and it will take 2 arguments. It will take a key. Let's do it like this. Unsigned char. No. Let's use our int 8. It's not really an integer because this is a string, but every every character is an integer, so it will be okay, I think. So int 8 key int 8, because if I don't do it like this, if I do sometimes char and sometimes int 8, and then I will probably get this signedness wrong, and I don't want that. And we will have an int 16 for the size of the key, and I don't need those. Int 8 pointer, int 16, right? Then we go back here and we will set our arc4 equal to arc4 init, and we send our key and our s key like so. And this is a function that might fail, but that's very unusual, so I won't care for that during this example program. But if you write a real production grade program, check if this arc4 returns 0, because in that case the malloc returned error. Otherwise we will get one of these structures back and then we are ready to encrypt. Let's add some prints as well. So initializing encryption, and I want to have a way of putting this to the screen instantly. So I will create a definition which I will call f, and I'm not putting this into the arc4.h because this is not something I need in the actual end result in code. This is just for convenience. So f will be f flush std out, and that basically flushes the standard output buffer, so that if I do a printf like this, which is not ending in a new line, it will, and if this takes a couple of seconds to initialize, then this text will not be printed before this delay, which kind of defeats the purpose. So I will put the f right after, like this, and then down new line. Okay, and then let's print out the input first. So I will put it in single quotes, and let's do it like this: a new line and then an arrow, and this is the from text, like so. Then we do the actual encryption. So we will use our encrypted variable. So encrypted equals arc for, let's define this first. So this will return a string pointer, but I will call it an int8 pointer, and it will be called arc for encrypt, and it will take two arguments, one which will be an int8 pointer, so the string that we want to encrypt, and a size in the form of a 16-bit integer, like so. Pretty similar to the initialize function. And the arc for encryption works like this. You don't need a specific decryption function, because if you try to encrypt the encrypted text, it will be decrypted. So then it goes backwards. So with that in mind, we can just create a macro which will be called arc for decrypt with two arguments, x and y. And this will just call arc for encrypt with x and y. So it's not really necessary, but it makes it a little easier to use. And in order to make this encryption function work, we need another function called arc for byte, which produces one single character of encrypted text. So this will be an int8 and not a pointer, just a value. Now that we have our data types and our function declarations done, we can continue with the example.c file. So the encrypted variable will be equal to arc for encrypt, and we will send in the from text, and we will also send in the size of the text, like so. And this is a function which shouldn't be able to fail, which means that the encrypted variable will now contain the ciphertext. The next thing we need to do is create a function which will make it possible to output the encrypted text in some format, because the encrypted text will not be printable characters. It will be any number of different integer values. And I'm thinking about using an output like this. So 1 byte will be represented by 2 hexadecimal characters, like this. So this is 1 byte, and then 2 bytes per group. And each group will be separated by a space. Okay, so this function will not be a part of the library itself, only this example file. So it shouldn't return anything, and let's call it print bin, because it's binary data. And it will take in an int 8 array pointer. Let's call this text. It's not really text, but whatever. And then we will have an int16 for the size, like this. And all we need to do is iterate through the text and print those bytes 2 at a time. So how do we do that in the easiest possible way? There are several approaches, but I think I will just create an int32 as an iterator, and I will have an int8 pointer as well. And I need to assert that size is bigger than 0. And what is assert? Assert is a function which checks if this predicate function is true, and if this is not true, the whole program halts. So it's quite good to use in situations like this, both in this example file, because it's easy and it doesn't matter really if the program exits, and we can also use it in our production code in some places, because we are coding a library and the programmer should send the right arguments. If not, the program should halt, I think. Alright, so we need to go into this arc4 and include what's its name? It's assert.age, and in order to get all the functionality we also need to include rnumber.h, like this. Now we'll jump down a little bit, same here. Okay, so we know that we have an input which is, let's call it input instead. That we have an input which is, which contains something. Length is bigger than 0. Okay, so let's do a loop then. So for, and we will do, let's make this an int16 instead. That will work better together with this 16-bit size. So let's, and I want to make this const as well. Same here. No. Okay, so let's set I to size and P to input. We're gonna continue the loop as long as I is positive. So I'll just put I here, because it will decrease every iteration, and it will, after a while, go down to 0 and the loop ends. And the P pointer will instead increase every iteration. Okay, so if, let's see, I need to check something out. So the first iteration, then let's say we have a string which is 32 bytes. So I will be equal to 32, and we will output to 1 byte of data. Then it will be equal to 31, and we will output 2 more. So let's see. I think we could write it like this. So if I plus 1, let's see. If I plus 1 modulus 2, if that statement is negative, so it's equal to 0, in that case I want to printf space, and in any case I will print out a hexadecimal value with two digits, and this is what we want to print out. I think this will be correct. So this basically means that if we are even, so if I plus 1 is even, then we will put the space. And we will also use our macro f, so it will print this. No, we don't need that, by the way, because we will end this with a new line anyway, so that will flush the buffer. This should be all, I think, unless I have forgotten something, but let's try it out. So what can we try it out on? We don't have all these functions yet. So let's comment this out, and this as well, and this is okay. And what shall we print as an example? We can print the key. So print bin, that's actually not binary data, but it will work the same. So we will print the key, and S key is the size. Return 0. Something like that. Let's see if this compiles, or if we need to remove something else. Make a lot of warnings. type def unsigned char expected before unsigned. Before unsigned. I have an empty struct, that's probably it. Let's just put something temporary here then. Type def unsigned. Maybe it is because of the position. Sometimes you need to do one thing before the other, etc. Forgot to end the struct with a semicolon. Is it still complaining? Type def unsigned char int 8. Type def. If we add our type def for our struct, does that error as well? Type def struct is arc4. It's not uploading. Okay, I got disconnected. One good thing with Sociopath is that if you reconnect like this, you don't have to do anything else. It remembers and continues to serve all of your files. So that's good. Okay, let's say this again. And this one. And let's jump down a bit, clear the screen, and let's make it again. Okay, finally. Pointer targets in passing, argument 1 of print bin differ in signedness. Okay. So this is what happens if I don't use my int 8 everywhere. So where did I not? Here. Let's just change this to int 8 and everything should be okay. Okay, we're down to one screen of errors and warnings. Almost. Does it still? Seems like it needs a typecast because the strings are generally not like these static strings inside of the code. They are generally not unsigned. So let's do a typecast int a pointer, and same here, int 8 pointer. Sterling key. So strlen needs it as well. I could just make these strings signed, but then I would have the same problem in the other end instead, because the encryption standard requires them to be unsigned. So let's just typecast this as well, int 8 like so. Do we use them anywhere else except our own functions? Printf shouldn't care, right? Let's do it just for the sake of it. Int 8 like this. Okay. Let's try it again. At least we have very clear and precise error messages in C. Did I go too far? Make clean make. S key equals S. Didn't I save? Save. Why does it... Okay, it's higher up in the code. Right. Int 8 star. And there we have it. Okay. That should be all right. Make clean, jump down, make. What does it say this time? Pointer targets in passing argument 1 of string length, different. I did it in the wrong direction. Okay. That's kind of funny. So instead of int 8 here, let's see. There, and there. We should just have char, because we have them as int 8, but the functions we're calling requires them to be regular strings. So assign char pointer. Okay, this time it should look a little bit better, I think. Make clean, jump down a bit and make. Warning, pointer target in assignment from char to int 8, aka unsigned, different signed as. So it doesn't seem to be enough by doing it this way. Okay, let's do it the other way then. I will undo until I see this change, like so. So now all of these are okay, and this will probably not be, but here we can do a conversion in the other direction instead, and that should be all. Make, clean, jump down, make. Okay, now we're talking. Warning, unused variable. That's an annoying message. If I don't want to use my variables, I don't use my variables. But okay, so let's do something like key equals from equals encrypted equals decrypted equals key equals 0. Is that enough? Maybe I should end it with a semicolon. Operation on key may be undefined. Variable as text set but not used. Right. So it wasn't enough to mention the key twice. This is only set and all of these are used. So we need a key. What about from equals key? Okay, now what? S text. But that's an int, right? Yeah, I haven't used that yet because we haven't gotten that far. These are only warnings, by the way, but when I try out my code, I want to remove everything of the sort. So which is this? This is the S text. So we will change the key later on. Let's just do S key equals S text equals 0. Now it should be completely warning free, I believe. No, one more. Warning unused variable arc4. Okay, I haven't used that. I can just comment that out for now. Make, clean, make. Okay, finally. Let's see if this works as intended. Example. Okay, so shall I compare the to summer's day, and then I am showing some of the key, but I am showing half a group here and half a group here. What will happen if where is it? If I just do I here. Okay, now it looks good. It prints out in hexadecimal characters in nice formatted group. Very nice. That means we can begin with the actual encryption code now. Finally. So let's go over to the arc4.h and begin working on our structure. This will contain the internal state of the encryption engine, so to speak. So let's go to that wonderful Wikipedia article. So arc4wiki, and I want the English speaking Wikipedia. And let's hide this and make it a little bit bigger for you guys. And let's do something like this. Let's use the whole screen. I will probably be looking at this anyway. So there's a lot of text here, and some of it are warnings that this encryption standard isn't secure. But I have read through all of that, and I'm not sure if I agree, actually. Well, the thing is, they claim that the output of the encryption is distinguishable when compared to purely random bytes of data. And that could be potentially be used to backtrack and crack the encryption. And it has indeed been used. For example, the Wi-Fi encryption standard WEP used exactly this encryption with very small keys and a special kind of seeding algorithm, which they were able to crack it in the wild in a couple of seconds. But that's only in combination with the WEP technology. And there has been some talk that in combination with the TLS, the encryption standard on the web, it's also not safe, and it's not safe the first couple of bytes which it produces is not safe. So, since we are using this encryption firsthand in our own code, not together with anything else, and I will also create a mechanism which will disregard the first 500 million output bytes, which will stop all the other cracking techniques. So I think with a big enough key, which is randomized in a secure manner, I think ARC4 is still secure. Okay, so you don't need to read through the whole shebang, but those gray information boxes are very good. So there's two steps. Step one is what I call the initialization of the crypto. That's when you only take the key and you prepare the internal state of the encryption engine. And this is what you do. And then the next stage, which happens every time you need to encrypt 1 byte, or more exactly, produce 1 byte of key stream data. So then you do this. So let's start writing. No, let's begin by creating our arc4 struct. I will zoom in here a little bit, not that much, temporarily, so we can have both on the same page. So if we look through this, what do we need? We need an 32-bit, or we need an 8-bit int, which will go from 0 to 255. We will need an array called S, which will be consisted of 8 bits values and 256 of them. Then we have the J value, same as I, 1 int, 8. And then we have the key. And that's basically it. So let's summarize. We need int I, int 8, I, j, and later on we will need a k, so I'll put it here. And then we will need the array, so int 8, s, and 256 of them. So we have I, we have j, we have the k, and we have the s. Do we need anything more down here? We need temporary variables as well, but I won't put them in the struct. So, okay, this is all we need for our own structure. So let's begin writing on our initialization function. And this will, let's copy this whole thing. Let's include our arc4.h. There's something weird going on with the caps lock. Include arc4.h. I wonder if you can disable the caps lock. I never use it anyway. I use shift. Okay, let's see. Include arc4.h, and then we will do the initialization function. So it will return an arc4 structure pointer. And the first argument is the key. The second is the size of the key, like so. And the first thing we need to do is allocate space for the actual structure. So I will create a pointer for that. I'll just call it P because we're going to reference it quite a lot. And P should be equal to malloc, and it should be the size of struct s arc4. So the size of our struct, that many bytes of memory we shall allocate. And here I will do an if clause. So let me just check the return values for malloc. Man2, no man3 malloc. So I know it returns the memory address, but if it fails, return value. They return null and they set error num. Okay, so let's just do something like assert p error number. Then it will check if this has errored out, and if so, display an error message and quit. Because if you can't allocate memory for our structure, there's no point in continuing the show. Okay. So now that we have allocated our structure, now I will just do this. And I will work in the following manner. Let's close this down and change up the size a little bit. And then I will paste this in and make block comments out of it. I think it's command this or control this. Let's do something like this instead. Annoying. I never seem to learn VS Code for Mac. I know all of these different things on my PC, but it's not the same on my Mac. Well, this works too. Okay, so now I have in the comments what needs to be done, and then I will just do it. But before we begin, I want to zero out all the state variables. So let's do something like no, let's just do simple thing. Int 8 x and 4 x equals 0, x less than 256, x plus plus, and we want to take the PS, so that is the this array. I want to zero that out. So ps of x equals 0, and then I'll just do pi equals pj equals pk equals 0. I like starting from 0 instead of randomness. Okay, so the first thing is this loop right here. We'll iterate through 0 to 255 with this I variable, and we will set s of I to I. Pretty simple stuff. The code will look kinda difficult though, but it really isn't. Why is this not? Oh, never mind. Okay, so for pi equals 0 and pi less than 256, pi plus plus, and ps of I equals I. Okay, this is done. So if we do one thing at a time, it's quite simple to do this actually. Can't say that for every crypto. And then we will set j to 0, but we have done that already. So we will jump into this loop and we will let the I variable do another identical for loop. So let's just copy this line. Like this. And what will happen then? We need two temporary variables as well, by the way. So we need int 8, I will call them temp1 and temp2. And I want to 0 them as well from the beginning. So let's just do temp1 equals temp2 equals 0, like so. Okay, so what will happen inside of this loop? Let's remove the things we have done already. Okay, so this is a rather difficult line. I want to break them down. So what's the first thing that happens right here? Well, the parentheses is evaluated first. So let's set, let me see, key I mod key length. Actually, let's evaluate this first. I mod key length. So temp1 will be equal to key. So it will be key of I no, where am I? We are here, right? So I mod key length. So P arrow I modulus key length. So that's the size. Okay, so this part is okay. Now we can take the rest of this parentheses one at a time. So P, J, no, temp2 equals pj plus ps of I plus key of, and then the stuff we evaluated right here. So key temp1. And then we will set pj. So now we are doing this part. So pj should be equal to everything in this parenthesis, which was temp2, and mod 256. Modulus 256. Like this. And finally we should swap the values of s of I and s of j. So let's set temp1 to ps of I. No, not just I. We need to change those occurrences to pi. And pi. There's a lot that can go wrong here, as you can see. You need to be very precise. So temp1, and that is why I could do everything in one line if I want to, but it's very error prone, and that's why I break it down with these temporary variables. So temp1 is equal to PSPI, and temp2 is equal to PSPJ, and then we will just swap them. So PS of PI equals, and here we see that temp2 equals this. No, temp1 equals this that I'm working with now, which means it should be equal to temp2 instead. And then we have PS of PJ which is currently equal to temp2, and it should be equal to temp1. And that's it. The code is very difficult to read, but it's quite simple, and it's quite easy to follow it step by step if you break it down into smaller steps. And that is basically it. I'm gonna do one more thing though, because if we go back to the Wikipedia page and we go to the next step, we see that they zero out I and j, and then they have an endless loop which happens every time you encrypt a character. So we have a function which encrypts a character, which means we only have to worry about this. But this part we should put here in the initialization function, because then we can just do several consecutive calls to our arc4byte function. So p of I equals p of j equals 0 like so. And then we just return p. I think we did it right. If we go back here and we remove this line and put this line back, then we can print, instead of printing the key, let's print arc4s. So the initial state of the encryption engine, and I will put one of these on top as well, so we may see the difference. No, sorry, can't do that. We haven't initialized it yet. But okay, let's see what happens. Clear, jump down a bit, make clean, and make. Okay, couple of errors. If we go to the very beginning, warning, suggest parentheses around assignment used as truth value. Well, I want to use it as a truth value. I don't really care for warnings like this. If I want to code it this way, I will code it that way. Implicit declaration of function assert p error, okay. And here I forgot something. And arc4 has no member named S, okay. So a couple of small typos. If we begin in the H file, I guess this is the problem. Is this a big S or small s? It is a small s, so why doesn't it have a member called S? Did I perhaps arc4 P? That's weird. Maybe it's something because of this. We should check if x is less than 256. So that was an easy one. And what else? Assert p error. Where is that located? Man 3 assert p error. Okay, I need this GNU source thingy. Let's try it again. Make clean, jump down a bit, clear, and make. Boom. Okay. int8 ijk unknown type name. Unknown type name int8. I put this before these. Let's move them. Like so. I don't like I have to break this up, but what can you do? This is just a warning. Error I undeclared. Okay, I missed one. Line 18. Wrong file. 18. So this should be PI, and this should also be PI. Okay. What now? Error arc4 undeclared. No, the problem must be higher than that. Arc4 undeclared in example, and pointer targets in passing, arc4 init key char star. That's weird. Didn't I use my int8 for that function declaration? Let's check it out. So int8 key and int8. That's weird. Let's put this back, by the way. And okay, it's this function. int8 input. In16. Well, where is it? Let's check it out again. So, expected int 8, arc4 init key. Pointer targets in passing argument 1 of arc4 init differ in signedness, because this is a char. int8 key. So key is a char. Okay, let's typecast it then. Where do we have it? It's right here, okay. So it's currently a, let's see, it should be an int8 pointer, So, okay, let's see what we have. Still a warning about this one, but that's nothing we can do anything about. Undefined reference to arc4 init. We need to link that one. Let's just no. So go into the make file, and then we will do. Let's make it easy. I will just do arc4.so as one of the input arguments. So make clean, clear, jump down a bit, make, and now it still doesn't compile. Undefined reference to arc4 init. What did it run? GCC arc4.so. Arc4 init. Do I include it in the header file? Include arc4.h. Include arc4.h. arc4 init. Undefined reference. Okay, for the time being, let's cheat a little bit. I will fix this later on. I don't have the patience right now. So I'm gonna go, and when we compile final program, we do arc4.o instead. Like so. Okay, this time it worked. We probably need to explicitly export the functions when we use the shared library. I will dig into that in a little bit, but now we do have ourselves a binary. So let's try it out. That doesn't look very good. Let's do ltrace-f malloc arnum location. Let's try the strace. Right, initializing encryption. How did I write that if clause, by the way? Maybe I reversed the conditions. Let's see. If p malloc. Okay, this should be the other way around. So if p. Alright. Make clean, clear, make, and we'll run example. Did it remove everything when I did make clean? Arc for CHC. Yes. So how come it freezes there? Malloc size of struct S arc4. If that is 0, assert p error. For x equals 0, x less than 256. I think that 0 means that it's some weird number format. Okay, no errors at all, no warnings even. But the same outcome. What is this? Do we have an endless loop on our hands? That's probably the only possible thing, right? So pi equals 0, while pi is less than 256. Maybe we should do this with a little bit bigger structure. These could be int 16s instead. We're probably overflowing that 8-bit variable. So that wasn't the case. For x equals 0, and what is x? X is also an int 8. So that should be the same problem then. Right. There we go, finally. Okay, so this is part of the internal state of the encryption. Okay, so the next thing we need to do, that is creating the arc4 byte function, which will create one single byte of the key stream. And the key stream is what we will use to encrypt and to decrypt stuff. So let's begin. I will have int 16s with temp1 and temp2, just like before. And we do need an argument, by the way. We need to attach the structure. So let's alter this and put in the arc4 star, so we can have access to the internal state of the encryption. And just like before, I will go to the Wikipedia page, and this time I will copy this part. So in this pseudocode right here, they use a while loop, and they loop as long as it's generating output. But we'll not do it like that. Instead, this function will be called each time we will produce 1 byte. So we don't need this loop. That will be handled in the encryption function. So let's do it like before and take one line at a time. So we will do pi equals, and then pi plus 1, and we mod it with 256. First one is done. Then we do similar with the j part. So pj equals pj plus ps of pi. So we just replace the variables with our variables inside of the structure. And we mod this with 256, just like before. Okay. Then we will swap the values. So this is like we did previously with the initialization function. So I will let temp1 equal ps of pi, and temp2 will equal ps of pj, like so. And then I will just I missed the s right here. And then I will just do ps of pi equals something, and ps of pj. ps of pi, ps of pj equals something. Okay, so temp2 equals the j part, which means it should equal the I part now. This equals temp2, and the pj should equal temp1, like this. And then this one is done as well. Why did it mess up the indentation? Never mind. Okay, and then we have this t variable. That is their version of our temporary variables. So we'll just continue as before. So temp1 equals, in the parentheses, ps of pi. So this is not really a spectator sport. I hope you don't find this too boring, but we're almost done. Plus ps of pj, and then we mod it with 256. And then we use the k variable for the first time. So p.k equals p.s of temp1. And this is the final output byte, as we can see right here. So let's take care of these indentations. And then at the end we just return pk, like this. And then we have our arc4byte function, which is the most important in this entire project. So the next step will be to implement the arc4encrypt, and this is quite straightforward to do now that we have a arc4 byte function. So let's see, we need one more argument. We need to include the arc4 structure. So, or do we? Yes, we do. Arc4 star. And we go here and do arc4 p and int 8. This will be the what shall we call it? The thing we need to encrypt, the clear text. Let's call it CT for clear text. And int 16, this is the size of the clear text that we want to create. And we'll return this as a as a char buffer, a regular string actually. So let's create a int16 which will hold the amount of memory we need to allocate. So let's call this mem size, and we will need exactly as much memory as this size plus 1. Okay, so we don't really need to, because when you encrypt something, if we encrypt ABC, the resulting ciphertext will be something like this. It will be the same number of characters, which makes it quite convenient for us. We don't need this variable. Instead, we'll just do, let's create a variable first. So let's call this ciphertext. And let's call this clear text, because both will abbreviate to CT and we can't mix those. So int 8 ciphertext, and ciphertext will be equal to int 8 malloc, and we want size +1. Size should be enough really, but I like allocating one more just in case. We will also need something we can use as a counter. Let's call this int16x. We will do a for loop where we set x equal to 0 and we're gonna loop as long as x is less than the size and x plus plus. And what are we gonna do at each iteration? Let's create a, let me see, we need this and that. Okay, let's do it like this. So the ciphertext of x will be equal to the clear text of x, and then we take this symbol, and some people usually mix this up with the power of, but this little symbol in C means XOR. So XOR is a binary function. Like, if you have 2 zeros, the result will be 0. If you have 1 0 and 1 and a 1, the result will be 1. If you have a 0 and a 1, so the other way around, it will also be 1. And finally, if you have 2 zeros, it will be 0. So that is what XOR is. It's usually used in conjunction with the key stream that a stream cipher like ARC4 produces. So here we will just call ARC4 byte with our P, and that will return 1 byte of key stream, which we will XOR with a clear text, and that will produce the ciphertext. And let's do an error check here as well. So if ciphertext is 0, then we want to assert p error r number, like so. And if everything goes well, we will simply return our new buffer ciphertext. Quite simple, straightforward encryption function. And we need a decryption as well, but that we have already defined because it's the same function, just that we give it the ciphertext instead of the clear text. And the key is the same, so basically this part is the same. Okay, so that is done as well. And before I forget, let's C encrypted equals arc4. So we can take this back now, and we encrypt the clear text, and we print out the encrypted. Sorry, this should be the size of the text. This should be the encrypted, because this time we don't want to check the S variable in the structure. We want to see the actual encrypted text. Yes. Okay, so after we have printed the text, what do? Do we just use the decryption function? No, we can't do that, because in order for everything to be the same, we must uninitialize the arc4, and we need to reinitialize it with a key again. So we start everything from scratch, and then we can start to decrypt. Otherwise it won't work. So let's create our uninit function as well, and that can be a void arc4. Let's make it easy for us for the time being, because there's only one thing we need to do at the moment when we uninitialize, and that is to free the memory allocation. So let's define arc4 uninit of x as free x. I will also need to find, let me just do a fast googling after export C shared library function, because there's a special string we need to use to export the functions. Let's see. This one. So let's make a definition. We define a keyword named export, and it will be the same as this. So all the functions that we want to export, like the arc4byte function, we don't need to export that, because the end user will only use the encrypt and decrypt functions and the init. So we put export for this and before this, save, and we need to do the same here. So export, and not this one, but this one. Export. Like so. Okay, so that is done as well. Now we may continue our example. So we have printed the encrypted strings. Now we're gonna uninitialize. So we do arc4 uninit on the arc4 pointer. Then we repeat some of the steps like before. So let's copy this part for Init. There we go. And let's create another one of these. Encrypted. So I will copy this part. Look for Init. Okay, something like this, and let's put the arrow 1, 2, 1, 2 like this instead. Okay, so we initialize and we need to change the order of these. Because we need to decrypt this first. So it's initialized. Now we will create our decrypted. So decrypted equals, and we will use the decrypt function, but as you know, it's the same. The only thing we're going to change is the from. Here we had the clear text before. Now we will do the ciphertext, which we get from this encrypted call. So where were we? Decrypted equals, and this should be encrypted, and everything else is the same, and this should be decrypted as well. And then we don't need to print the binary. Okay, so if we have done everything correct, then the decrypted text should be exactly the same as what we had from the beginning. So we take the text, we encrypt it, and we decrypt it back to the start, so to say. Okay, let's save, and we make clean, jump down, we clear, and we do make. Okay, not a lot of errors and warnings. Let's start from the beginning. Error T undefined. Size plus T. Text 54 in arc4.c. 54. Ciphertext. Size plus T plus 1. Should be plus 1. Okay, we got more errors. Let's do make clean first. Make. Okay. Warning, this for clause does not guard for x equals 0 while x is less than size x plus plus x equals 0, x is less than size, x plus plus. That shouldn't be a problem. This state doesn't guard this statement, return cipher. But the ladder is misleadingly indented. Okay, so it even checks my indentations thing. But sometimes that's good, actually. I have corrected errors in the past because of that. So let's see what it says. Okay, it's this part. Let's move it here. We make clean, we go down, and we clear, and we make again. Okay, passing argument 1 of our for encrypt from incompatible pointer type. Arc for encrypt from. Okay. Let's see. Arc for encrypt from. Encrypted equals arc for encrypt from. And from is set to this. Okay, we probably need to typecast this down. But it worked before, right? Oh, never mind. Int 8 star. Let's do it like that. Do we have any more occurrences of the same? Decrypted. No. Okay, let's try again. Make clean. And make. Arc for encrypt from incompatible pointer type. Encrypted equals. Wait a second. I forgot to attach the structure. Right? We did change the signature of that function. So where were we? Arc for encrypt. The first argument should be the arc for, like this. And same with the decrypt. So arc for, and we need to add a variable to the macro as well. So x, y, z, x, y, z. Like so. Let's try again. Make, clean, clear, and we make. And we have this signedness problem again. So encrypted equals arc for encrypt. Arc for encrypt. So let's see. So encrypted, how did we declare encrypted? Okay, let's move this to its own instead. Decrypted. Decrypted as well, I think. So int 8 encrypted, decrypted. and we make clean, and we clear, and we make. Okay, almost there. Another, okay, that's our temporary assignment. We don't even need that anymore. So let's just remove this part and this as well. Save, make clean, clear, and we make. Okay, it compiled. Let's see what happens. Okay, initializing encryption done, and then it shows the string that we want to encrypt, and it shows the hexadecimal version of the encrypted text. Then we reinitialize, we feed it with the ciphertext, and we end up with the same string as we had from the beginning. So everything works. The only thing we should add to this, that is remember when I talked about some people think that the ARC4 encryption is not safe. One of the biggest concerns was that the first thousands of or millions of bytes is not good enough, so to speak. So we need, when we initialize, we need to, I call it to whitewash. We need to whitewash away the first 50 or 500 million of these. Yeah. So let's go into our encryption function. No, our initialization function. This one. And I want to create an int32, which I'm going to use as a, I'm going to use it for a for loop, basically. I don't really want to call it I, because that makes it interchangeable with this pi. So let's just call this C for count, N for number. N is good. And let's go into the, let's see, ARC4, and we create a macro for this. So we define ARC4 whitewash, and we need we don't need an argument actually. And what we're gonna do, by the way, we do need an argument. Let's take the variable for the loop as an argument. So the only thing this macro will do is a for loop where we go from x equals 0 while x is less than let's call it whitewash count, or whitewash, let's call it m's. So these are millions of iterations. So x is less than ms times 1, 1, 2, 3, 1, 2, 3. And I plus plus. And the only thing we need to do is, okay, we need one argument more. the only thing we're gonna do, let's do it on the next slide. We will call arc4 byte with the structure or a pointer of the structure as an argument. So basically that. We will call this, which it will generate a byte, and each time it loops it will do that. But we're not going to do anything with that byte, because all we need to do is getting ahead in the in the state, so to speak. But if we do it like this, then GCC will recognize that it's redundant, and it will, as part of the optimization, it will just remove this. So we will need to typecast this to something called volatile int 8, like so. And that basically means, in this context, that the GCC should not optimize it. Okay, so let's put this as part of our initialization. So when we are done with the rest of the initialization steps, at the end here we will simply call the arc4 whitewash and specify our variable for the iterations and the name of our structure, which is P, like this. Okay, and if this works, we should see that it takes longer when we run this initialization, a couple of seconds. We also need to define the m's. So how many million iterations should we have? And I want 500 million. I think that ought to do it. If you think it takes too long when you run this, try changing this to 250 or 100, because I have a quite fast CPU, so this should go quite fast. And we save everything, and hopefully we haven't introduced any additional errors. Make clean, and we clear, and we make. Yes, we did. Okay. What does it say? Okay, I++. That's wrong. Where were we? Here. So it should say X++, right? Alright, let's try it again. Make clean, go down a bit, and we clear, and we make. It compiled. Let's run it. Initializing. And as you can see, it takes a couple of steps, and then it does the same as it did before. Only this time it's probably safe. As long as we have a really good encryption key, which we don't at the moment. At the moment we only have, in this example at least, we only have the word tomatoes. We should randomize a 2048 bits key if we were to use this in the wild. But everything works exactly as we intended it to. So we have successfully implemented the ARC4 crypto, and we have turned it into our very own library, which can be shared between different applications. And when I create a project for transferring and encrypting files, I will use this library for that. So then I will show you how to use this library in your code. But I hope you enjoyed this, and don't forget to subscribe if you like this and want to see more. There is a lot of advanced C videos coming forward, so don't miss out and stay tuned. Thanks for watching, and thanks for today.